Hello and welcome to tutorial 21, where we are building some kind of Minecraft thing using just Python, and we're doing so by using Peter Amland's Ursina module, which you can find online with instructions of how to install it, etc. So well, I was just introducing as many bugs as possible. For example, when we mine some blocks, collect them, we can go to the inventory by pressing E in our system. That brings up the main panel. If I click on an item that we've collected, we get the stack number. So there are six grass blocks collected there. But then the which is good. So we coded that last time. We've got text on the screen, and we're keeping track of the number of collected cubes. But if I then go and collect some stone, it just stacks itself on top of the grass block. So that's not great, which is weird because if actually let's just run the code again. During my earliest testing, as long as I don't go and create that text, for instance, there's some stone, there's some grass, get some stone, get some grass, let's go and get some soil, etc. Whoops. You can see that on the hotbar, which I'm calling the little inventory at the bottom, that hotbar is working correctly. The problem is only introduced when we just select one of the hotspots there. So if I click on this guy, presumably that will be okay. But then if I go for soil, will that go to on top of the grass block? No. So I can't even reproduce the bug in this instance. Anyway, we saw the bug the first time round, and the problem is with what we were creating in the last video, which is in the inventory system under fixed position. Am I in the right place? I am. So there's a function called fixed position, which is part of the items class. And so what this function, just to remind ourselves again, is when we drag and drop one of the items, one of the little 2D block types, I'll go and find the drop function. There we go. It calls, the first thing it does is call this function fixed position, which just snaps it to the grid of our inventory. But the problem that we're having is down here. So our new code. So basically, I'm saying there, if the closest hotspot exists, which means we found a new space to a hotspot to snap to, the first thing we say is the position of our item on the inventory equals the position of that new hotspot. So far, so good. Then we say that this hotspot we've just found is occupied. We say its item, i.e. the item that it's storing, that it's hosting, is this, and this just refers to the instance of an item belonging to this item class. Then we're saying this is very new. We're saying that hotspot's stack now is whatever number of stack we had in the previous hotspot from where we've dragged the item. So that's fine. But then this is the problematic bit of code, and it's kind of like legacy from my old code. I'm kind of saying if we have dragged it from somewhere, which is always going to be true. So I'm really there just testing if we have dragged it from somewhere, i.e. it's not just being instantiated from somewhere else. So I think I've put this in here to prevent a previous bug, which no longer will happen. So, well, I say that, we'll find out. So I think we can do away with that guy. But then what I'm saying is this new line here, actually, let's just sort out our indentation, I can press Shift and then the Tab key, and that like does an anti-tab. It removes the tab, which is very useful for multiple lines. So just hold down the Shift key as you do it, it'll take away the tab. Very useful for Python programming. This line is new as well. We're saying that if the current hotspot, so the current place that an item is, doesn't equal the new hotspot, then do some stuff. Now, the reason why I'm checking to see if the current hotspot and the new hotspot are different is because if we just click one of the items, this function, fix position, being called by the drop function, will be called because the way Ursina has been built, if it notices you click something, then it's assumed that you've kind of like dragged it. But I didn't want to go and find a completely new hotspot. I just wanted to find the closest one, which includes the one it's already on. So anyway, this just means we can click items and the item will stay where it is. But we've got to sort some things out. We want to say, well, if it is a new hotspot, then yeah, that new hotspot stack wants to be set to 0. Sorry, the old hotspot wants to be set to 0. So the old hotspot will be the item's current hotspot. Apologies if this is confusing. Then we also want to overlay a load of spaces on top of the text display of the stack number. So that makes the stack number disappear, which was useful. But then we are updating our hotspot. Oh yeah, saying now our current hotspot will be this new one that we found, which we don't need to do if they are the same. So that needs to be part of this indentation. So this is the problem. If we're saying this current hotspot occupied is false and it doesn't have any item, that's going to be bad news if it's the same hotspot, i.e. we're just vacating the hotspot where the item is and then we're not moving it. So that's why we're getting that strange bug. We're basically emptying an occupied hotspot. So I need to, cut those from there. And place them there. So I need to only empty them if it is, we only need to empty the old hotspot and say it's got no item there if we are indeed moving to a different hotspot somewhere else in the inventory on the hotbar. And then finally, we can just update that this item has a new current spot, i.e. the place where it's actually moved to. Okay, right, and that final bit we can leave alone. It looks like, yes, there's no available hotspots, so just move to your old position. Right, so let's go and see if we can now avoid the bug. We'll try and recreate the condition. So all I have to do is collect some grass. There we go. Now if I collect something different, no, now I have to bring up press E to toggle on the inventory, and I click my collected items. Now if I go and collect something, it should go to the next hotspot. Yes, that's brilliant. And can I just drag things around? Lovely. So the text disappears from there, and I still get 3, and I get 3 over here. Did I just collect 3? Let's go and collect some more. Do some blister mining and click loads of things. Good, good, good. You can see that's, well, you might not be able to see the stone. It's a very similar grey, but it has occupied the available hotspot. Notice I'm collecting loads of things, but we're not updating the text on those stacks. So that would be useful to do. And maybe we could make the text black as well. And now I'm stuck. But let's go and see how many we've got. We've got 11 there. And look, oh, the text hasn't disappeared from the hotbar, nor has it disappeared there. That one did disappear. That's interesting. So we're getting some text stuck, and again, when I toggle off, the text isn't disappearing. Okay, so a couple of things to look at there. Right. Okay. Here are my notes for this video. So bug item text remaining when it shouldn't. So we just saw that. Items of different kinds overlapping. That has been sorted. Done that. Deplete stack number when building, and then of course trees. That's what we'd love to get to. Good. Right. So what was the text remain when it should? Let's add another kind of like feature there. We want the item stack text update upon collection. That's what should be happening. So in our collectible system, when we call check pickup and we've picked up a collectible, then we're playing a noise, and then we're calling the item static method new item, and passing through what block type that collectible is. So we go into the inventory system, which is where the item class is. There's the item class, and we go down to new item, and then we're using our stack check method to go and see, have we already got some of that block type on the hotbar? And if not, then we have a look for a space. And if there is space on the hotbar, then we we begin a new stack. If it's true, is that in stack check? Oh, there it is. If it's true, that's when we increment the stack. So here, I guess, we need to also update the text on stack. Okay, where is our text? Well, there was actually another little bug. Oh, it's right here. In the drop method, we were asking the current, the hotspot in question, we were creating a text object, but in fact, late on in the video, we added that as a property of every hotspot from the get-go. There we go. So in the initializing function of our hotspot, every hotspot across the hotbar and on the main inventory panel, we are giving it a stack record, how many items it's got in that position, but also we're saying its T, i.e. its text display, is some text. Now the bug I was just talking about is originally we were only creating that text on the fly as we dropped an item, as we picked one up or clicked on it, as the case may be, which we don't need to do anymore. We don't need to create a new text item to put on top there. So actually that's probably responsible for some of the buggy behavior we got, because we've got multiple text entities flying around our UI. So I want to say the text objects dot text. So the actual text it's displaying is not a new text object, but is just the message or the string that we're building up here. I also mentioned that it would be nice if it were black. There we go. It might show up a little better. If we want to change the position of it, by the way, we can fiddle around with its dimensions here. I'm not going to fiddle around with any UI coordinates. They're notoriously difficult. But there we go. So we've got some text behavior. So this really shouldn't stay in drop. We should have its own dedicated function. I'll know how general to make the function because I want to do this kind of thing again. So yeah, I want to say, well, let's try and write it. Let's write it just above here. So this is going to be a static method, i.e. it's not going to belong, whoops. I was going to say it's not going to belong to every instantiated, where are we, item. No, it's going to be a general method. There's going to be a general method to oh no, it could. I was going to say, sorry, because the stack number relates to a hotspot, not an item. And remember, we're inside the item class. However, every item does have a current spot, i.e. the current place it's snapped to on the grid. So actually, we could make it a member function, which feels right. So let's go for that. So text, and we'll call it update, sorry, def update stack text. And because it's a member function, we want to include the this keyword as a self-reference. And then we want to do this kind of thing. Display how many blocks in this hotspot stack. So I can move all of that into its own dedicated function. And then just replace that with a call. I can say this dot update stack text. Fantastic. So that just reproduces the behavior, but now this is much tidier, making sense. And then hopefully we can use this. So what it does is just get the current stack number and just update the current text of the text object. So it doesn't create a new text object, it just updates the text that it's showing, hopefully. So I can call that in stack check. There we go. So now I can say oh no, okay, so this is a static method. h.item. So that's how we can get the item in question. So h.item. Update stack text. Let's see if that works. Oh, that's really satisfying. We can see the numbers incrementing. Wow, it's worked. It's worked straight away. Notice how the panda is always around when things are going well. When there are bugs, can't see him, can't find him. Whoa. Okay. Okay. What I didn't like is that we don't get a number 1. As you can see with the stone, actually. So if I go and click on the stone, then we do. I'm not sure about the black text. Maybe we will increase the text scale. So that was in the inventory system. In the hotspot class. There we go. Scale, we'll go up to 1.5. And yes, so we've got to think. We didn't get a number 1 because when do we get an item stack created? Well, that is in the new item function. Here we go. There we go. So when we first create one, so just in here, what we just need to do is after we've got our item and everything, maybe before we break, we just want to get hold of B, which is the item that we've just created, and we say update stack text. So now we should see that appear. Ah, good. I was just on the tip of my brain. I had some memory of in a previous, this previous tutorial to-do lists. I had something. The sounds for picking up an item wasn't that. Text for stacking info on inventory. Wow, we've done that. Stacking behavior on inventory. Done that. Disable collectibles. Ah, that was it. If far away from the subject, or destroy collectibles if lifespan expires. So actually we'll just replace that with this guy, because there's a simple way of doing that, using the destroy function actually built into Ursina. So we'll do that. Sounds for picking up an item. Yeah, we've done that. UI aspect ratio bug. So that's everything there. Okay, so I can go and do that. So in the collectible system, well, this is weird. I want to go to the initializing function, don't I? So this is where we're producing an item, instantiating a collectible, I should say. And the last thing we do is generate its model. And then we should say set collectible to destroy after some time. And all we have to do is use the destroy method from Ursina. We've got the red error wiggle because this module doesn't know what destroy means, because from Ursina we are only importing discrete functions like entity, vector2, vector4, load model and audio. We also need, after a comma, destroy. Good. That imports, and so now we can go down to where we were before. So we're in the initializing function of our collectible object, and we can say destroy this object, and then you put in the delay. So we could say after, how long should we give people? Well, I'm going to say 7 seconds. That feels a bit short. You could, put in several minutes, something like that. Let's go and test that. I just adjust my snood. Oh. Oh, another thing I could do, just looking at the terrain generating, I found a slightly nicer balance of numbers, i.e., God, if you cast your memory back to the subset width, i.e., how many blocks we're creating within one subset area of a terrain, like a chunk, and also the rate at which they're generating and the total number of subsets we're allowing ourselves. If you balance those numbers, you can get kind of faster terrain generation offset against like a smoother gameplay while the terrain is being generated. I mean, this is pretty good. I mean, I am recording. I was going to say it's just dipped to 12 frames per second, but I am recording at the same time, and it's playable. But it is noticeably smoother when you press G to toggle off the terrain generation. It's now silky smooth. presumably in the future we'll look back at optimizing some of that, but also including an intelligent mechanism by which we could like monitor what the player's doing, and then sometimes we could like hide the fact that we're generating loads of terrain and keep the frame rate smooth. That's way off in the future. But before that, we've got like mobs and crafting and biomes. Biomes would be a big one. And this, I think we're making good progress in this tutorial. So trees. Let's do trees. I'd also love something that's not in Minecraft, like rocks and weird formations. I've forgotten what we're doing. I should be collecting stuff. Aha! And looking at our new font, which is a bit bigger, and we are getting stacks of one. Oh, also, oh yeah, there's the panda. Things is working. Things is working. And so here he comes to bask in the glory, get some credit. I don't know why I'm kind of like picking on the panda. We used to be good friends. I think we still are friends. Oh, it's maybe because I've been thinking about making a giant chicken again. Oh, did you see our collectibles? Let's leave them there. They're all going to disappear after 7 seconds. Are you watching? Where are you gone? He's watching. Oh, look, there you go. Brilliant. So now that just say it's like a weight off our shoulders. We don't have to worry about our computers burning through RAM because it's got loads of collectibles. Ursina has tidied them up nicely. Okay. Let's try and destroy the success. So if I move some tiles around, press E, at least the tile kind of disappeared this time. But the text doesn't. Okay. I feel like I should move on to trees. Let's just see if I can sort that bug. One thing is, I'm not happy with the colour again. I think white looks nicer. You can, by the way, add a background to your text, which remind me in the comments to do. Maybe if you want that, if you want to see that, or maybe try it out yourself. And if it does work, let me know. If it doesn't, let me know. You can, as well as commenting in the comment section of YouTube, you can also go to the GitHub issues page, and you can include screenshots, and we can have more of a discussion there about anything relating to this project if you prefer. I can't find what I'm looking for while I'm talking. Here we are. Update stack text. Yeah, let's change that back to white. Remembering we're using these like HTML-like tags to do that. Okay. Good. So yes, we should have a toggle function. There we go, hotspot toggle. Which will be in the hotspot class, of course, which is near the top of our module. I should use the find search kind of like function, but I just scroll up and down. So we want to find somewhere where we can basically just say the text is invisible, or invisible if we're on the inventory. So I've got toggle non-hotbar hotspots and their items. Yeah, that's what I want. So for every hotspot, if it's gameplay mode, i.e. it's not visible, if you're not visible and you're not on the hotspot, then visibility should be true. That should affect the text as well. I don't know why it doesn't. So let's try and say h.t.visible visible equals true. If it's not on the hotbar, we can say its text is false. Let's just give that a go. If that doesn't work, I'll move on. I'll just add it to the to-do list, and then we'll have some more fun with trees. Have our first fun with trees. Yeah, white looks kind of bougie, kind of classy and luxurious. Nice. Good. So now, if I put some of those guys onto the inventory, at least they're appearing. E, the text disappeared. The text disappeared. Okay. Ooh, we need to put them back on the hotbar. Text does move across. E, text stays. Wow. Wow. Panda, I'm even feeling friendly towards you. Things are working very well. Okay, so let's quit that. That goes down there, and we'll save everything. So what can we say? Destroyed collectibles if lifespan expires. Done. Text remaining when it shouldn't. Done. Item stack text update upon collection. That's now done. Oh, deplete the stack number when building. We'll leave that on the to-do list. Let's go and plant some trees. Okay, let's keep this a short video, 45 minutes, so just over 10 minutes. What are we doing? So, mesh terrain, our old friend. So mesh terrain module, if you didn't know or can't remember, is the module responsible for actually generating our terrain, probably the most important module. And my idea, oh yes, I was talking earlier about generating terrain more silkily. I believe if I change that to 1024 subsets, and then the sub width dropping to 6, we might get some nicer, smoother generation. Let's just have a look at my prepared code. Yeah, 1024 and 6. And then in the main module, we're actually calling that generation function. I used to have like a counter system and then generate a lot of subsets in one like update frame in order to capitalize on speed, but that also knocks down the frame rate. So let's just see what I'm doing with those numbers. Plus equals 1, greater than 1, and then just generate it every frame basically, something like that. Okay, so let's just reproduce that in the tutorial code. So I'm back in the main module. Count is greater or equals 1. Count equals 1, and just generate terrain. Okay. Just before starting the trees, let's just see how that feels. Yeah, that is a bit smoother actually, and it is pretty fast, isn't it? Let's see if I can run. And the terrain does generate beneath my feet, or in front of my feet. Ooh, we almost fell off. Okay, so that's not bad. So I haven't got the fastest computer, and I am recording, and I'm kind of sprinting around, changing direction. I didn't fall off the terrain, which is good enough. If I press G, or if you press G to toggle that terrain behavior, then you can get your, oh hello Panda, you can get your 60 frames per second. I love this kind of creating like these strange roads, panda terrain roads. Um, it's a nice mechanic for a different kind of game. Trees. So back in mesh terrain, not getting distracted this time. What we essentially want to do is, yes, every time we place a block, so we've got generate a block, or actually generate terrain. So what terrain does is, yes, it's in here because generate block is kind of a general purpose function. We might use it indeed to grow our trees. So we don't want to grow trees upon trees and things like that. But in generate terrain, that's where we're looking at actually building our terrain and where we can think about caves and other things. What we can do is inside this two-dimensional grid, this loop, nested loop, where we're just describing like a chunk area and we're generating blocks within that grid. We set the width, by the way, to 6 by 6, so it's going to be 36 at a time. We can say every time we're going to call the generate block function and place down like a grass block or a stone block by random, we can say, shall we make a tree here? And we can do that randomly to randomly place trees. Or what is much better is to use Perlin noise again. So Perlin noise is the algorithm we're using to decide not random terrain, but a predictably landscapey, up and downy, undulating kind of terrain. In the same way, we could generate some Perlin noise separately to the terrain for areas of trees, and basically for a two-dimensional or a coordinate, it can have like a number attached to it. That's what the Perlin noise gives us, and we can say if that number is high enough, then put a tree there. That's what we'll do. So yeah, so we generate a block, and then basically on top of that block, should we make a tree? Plant a tree? Question mark. Shall we plant a tree? So what would be nice is to have a... Are we in a class? Yeah, we are. So it'd be nice to have a static function within mesh terrain for planting trees. So let's... I'm already doing this differently to my prepared code, which is not good news, by the way. Right. And okay, def plant tree. And we're going to need an X position, a Z position, and presumably that's it. Presumably that's it. And with that X and Z position, we can decide, we can refer to our Perlin noise, and we can anyway, build a tree. Right, so I need to find what is my X and Z position. Oh, I might also need the Y position here. So it's X plus K, Y. I guess that will be plus 1. Just want to build on top of that first block. And then Z plus J. There we go. So that'll all resolve to 3 numbers. An X, Y, and Z position. Okay. So that calls our new function, which will nice and tidily will be up here. Right up here. Okay. So now we need a y. Lovely. You might be thinking, why do I put an underscore? You don't need to do that before this parameter. It's just so that I know that it's a parameter of the function and it's not some local variable. It's sometimes helpful to do that. Okay. So then we want to go and do some Perlin noisy stuff. So we need a new module for handling a tree system. We need a tree system. So new file. Yeah, it's going to be a Python file, and I'll call it the tree underscore system dot py. And I do want to save it in our tutorials. Yep, that's in the right place. Create file. Great. Okay. Our tree system. So, before I forget, we do want to then, from tree system, import asterisk, import everything. And then, yeah, we need a function to, we probably need, yeah, let's create a class and we'll call it tree. Well, it's a system, so I'll call it tree system. And it can have a, I don't know if this is a nice way of doing it, but like, I'm addicted to static methods now. This is probably a silly way of doing things. I don't know. Define, we'll have a setup function where we whoops. Where we are going to create our Perlin noise object and set things up there. And then we're going to need like some kind of like function to generate tree. And that's where we'll pass in, again, presumably x, y, and z. We might not need the y here. I'm just writing the pass keyword as I'm kind of like sketching things out, because Python will crash if there's nothing within a function. So you can just write pass just to say, don't do anything, but we'll fill you in later. Okay, so back to our mesh terrain. Where were we? Yeah, we were in plant tree and we haven't got pass in there. So in here, the first thing that we want to do is from the tree system, we want to say tree system generate a tree at x, y, and z. It might be something like, really, we're gonna, well, let's go and see my prepare code for the Perlin noise stuff. So this will begin to make sense. So we need from the Perlin module, the Perlin noise function, first of all. Yep, it's been 45 minutes. We must get a little bit of a tree nub, something happening before I give up. So under an hour, here we go. Right, so we're in the tree system. We've got some Perlin noise, great. Back to the prepare code. Oh yeah, so I've done a tree system, similar kind of thing. I think some of my syntax is wrong there. Right, yes, in a setup function, here's where we're creating, there's not many lines, but we're saying we're giving our tree system a property of some noise. I'm calling it a noisy ent. An ent from like Lord of the Rings, and then noisy because of Perlin noise. And all we have to do is to pass into the function, the Perlin noise function, which we just imported, how many octaves. So that's to do with kind of how the Perlin noise will be distributed, all these numbers, the density of certain areas on the, if you imagine a map, will be, i.e. where there will be trees and where there won't be trees. And then the seed is just like a random number that you can put in. Okay, and then we can adjust the distribution of the trees using that octaves number, the seed number, but also the frequency. Okay, so let's see if I can reproduce that without copying and pasting. So yes, we want to say tree system dot noise equals Perlin noise, and then we pass in octaves. Octaves equals, I'll put those on a new line. Octaves equals tree octaves, I'll call it, and then seed equals tree seed. So we can say tree octaves equals 32, I think I had, and then tree seed, I'll say 22, since it's 2022. There we go. So we've got our noise object, okay, which we can then use in GenTree. We also need tree frequency, which, what did I set to? 64. So the frequency is basically the smoothness. The higher the frequency, the smoother or the more gradual a change over some terrain. In other words, if we would have like loads of trees and then slightly less trees, slightly less, slightly less, slightly less, slightly less as we move to different areas. For a high frequency, if we had a very low frequency number, then it would be very jagged, like loads of trees here, no trees, no trees, loads of trees, or just trees kind of like dotted in like a random way around. I've just noticed that should be a property of the class, not just a local function, a local variable here. So tree system dot, and then I could call that freak actually. Frequency equals 64, was it? I think it was 64. Oh, have I spelled system wrong up there? And then wrong again. There we go. Now we can all sleep at night. Oh, pass we can take away. Good. So now, in our grow tree, or generate tree, we are getting our Perlin number. So at this particular position, we want to say, are we going to grow a tree here or not, based on the number from the Perlin noise there. So we're going to store that in a local variable, tree system, get our noise, and then we're going to pass in, oh, it looks like it needs a list. So we're putting things in square brackets, and it's going to be the x position divided by our frequency and the z position divided by our frequency. And in fact, that's all put inside of a tuple. I'm curious to experiment with that, but I won't do that here because I haven't got time. Okay, so we're going to say check whether or not, check whether to generate a tree here. So we'll say, I'll just keep to tradition, tree will be just W, will there be a tree? Actually, I could just say, I'll use the word tree. Tree equals, no, let's be lords of the ringsy, let's say ent. Ent equals our tree systems dot noise, is it called? Noise, I think that's okay. Tree system dot noise. Oh, setup function, we need to actually call that. So when the mesh terrain imports this module, after we've defined the class, we can call tree system setup. There we go. That's important. So it's noise. This noise function or noise object, it will return us this number determined by the Perlin noise. Right. So as I was saying, this wants to be our x divided by the tree system dot frequency. I don't know why that's not popping up. I'm a bit scared of that. And then z divided by the tree system dot frequency. And that's it. And then wrap that in a tuple. If you want to find exactly why it needs it in that form, you can look to the Perlin noise modules, or look in an earlier episode where I first code the mesh terrain, and that's where we deal with Perlin noise. We do need to revisit Perlin noise for saving and loading files and different biomes and things, so we'll get back to that later. Okay. Now I think it's useful, or I have in my prepared code, just to add one to that. And then what we're saying is, well, we've got our number, which is not random, but it'll feel random. But each position on the map is related to surrounding positions now. So we don't just get a random dispersal. Prepared code, that's what I was after. Tree system. Yeah, and then we're just deciding two things. If that number is greater than 1.435, and I found that just by trial and error, seeing how many trees I get and things like that. So this is stuff that we can play around with in the next video probably. So if it's greater than 1.435, then return W. So we're not just returning 1 or 0, i.e. make a tree or don't make a tree. We're returning 0 for don't make a tree, but W also tells us the strength of that kind of number. So that's useful because we could say, if we get a really big number, let's have a really big tree. And that size will be related to other positions on the map. So it makes sense to have loads of big trees over here and smaller trees and things like that, because the environment works that way. And we can fiddle with that baseline. But I love this kind of stuff, this molding of the environment of the world. But anyway, let's go and add that to our code and grow a tree. So if ent is greater than 1.435, was it? Then return that number, else return 0. Great. Okay, so we're finished with our tree system module. Remember to call the setup function of the tree system, which will just run this static method to set up um, the noise object for our tree system. So that only happens once, and then we can keep calling this generate a tree query really, and we don't need to pass in the Y position, so I can take that out. If I go back to mesh terrain where we're calling it, so we're calling that from plant tree. Oh look, there's tree system, there we go. We can take out the Y there. We do still maybe need the Y here because we need to know where to build the tree. So now we can say, I'll use ent again, ent equals tree system, because remember the generate tree function returns that number. And then we can say if ent is 0, return. There we go. So we know we're not building a tree, but if we are building a tree, then maybe we just want to go build up a load of cubes or generate blocks on top of each other set to the tree's block type, which we haven't got yet. It's not been an hour yet. Let's keep going. So we can say for I in range from, well, let's go from, let's just go from our Y position, which is, remember, one block above the terrain block. So that's good. So we can start at 0 to maybe ent. Let's just put an ent. But that number presumably is going to be very low. And by the way, when I was trial and erroring this, I was just printing out into the console what numbers I was getting. Let's just say ent times 10. We might get really tall trees or something. And then we just want to say generate block. So mesh terrain generate block. So I need an X, a Y, and a Z. So X, Y, Z. Oh, and the Y is going to be plus I as we go up the tree, depending on how strong the tree number is. What else do we need for generate block? We need the subset. So I need to pass that into the tree function. Generate terrain. Oh no, I don't. Doesn't look like I need it. Okay. What I can just copy is this stuff. I just need an X, Y, and a Z. That's good news. I can't find the tree. There it is. Right. X, Y, Z. Block type. Let's just set it to concrete. Let's get like white trees for now. And laying terrain is false. Oh, I think that was because if we are laying terrain, then in generate block, where is it? Yeah. If we are laying terrain, then we get stone blocks and we get snow and things like that, which is going to be refactored. That shouldn't be in here in this function. We should do that in the terrain building. But just like a hacky thing to do. In other words, we don't want to be laying terrain when we're building a tree. Right, have we got a tree? Surely not. Oh, good. Okay. It says type error. Float object cannot be interpreted as an integer. So that's in our, going back in mesh terrain, when we're using a loop for I in range, you can't just use a floating number. This must be an integer. So if we just wrap that with some integer casting, int wrap the floating number, the naughty little floating number, in some brackets, and that converts it to an integer. So that wasn't too bad a problem. What's the next problem going to be? Oh no, I didn't think there was going to be one. Generate block, missing one required positional argument, Z. Did I not put Z in there? Well done if you spotted that. I swear I put X, Y, Z. I haven't got the commas mixed up or anything like that. No, it looks fine. Let's just run that again, see the message. I didn't really look at. In generate block, concrete. Missing one required positional argument. Let me pause the video. Okay, I think I've solved it. It's because I'm getting too enthusiastic about static methods. We only have one instance of the mesh terrain, so it's not a waste if I make this a member function. So generate block is not a static function, but I'm treating it as though it were one. So really, it's a member function. So this generate block should now work. That's scary. Why are we getting that there? Oh, because now it's a member function, I need a reference to itself as a first positional argument. Aha, okay. So that was a bit more of a scarier bug than we're used to. And that's a good one. I'm glad that we went through that together. That can be intimidating. Right, we're getting a similar thing going on here. Mesh terrain, plant tree, requires a positional argument, line 176. That's because I forgot to change this as well. So plant tree is now not a static function, it's a member function. This, go and plant a tree, please. This mesh terrain, go and plant a tree. I need to go and find out more about static methods and decorators and architecture within Python. Talking of architecture, we have concrete trees, or concrete poles. Oh, they're great. I love them. Okay. Can we mine them already? Ah, look at that. Yes and no. What's kind of cool is that because we're mining, we've only anticipated mining the ground. So at the moment, wow, it's treating trees as digging under the ground. So it's creating these like walls of the terrain or soil deposits, which is kind of cool. You can kind of like paint some landscape. I'm holding down shift, by the way, to mine really quickly. That's really cool. Right, but notice the bottom of the trunk, the bottom cube, works correctly. That's because there's a gap or a gap block, a secret invisible like a block of air over every single terrain block, which means that we don't get blocks being generated like walls. I call them walls, don't I? Soil walls around. Anyway, that's something that we can sort out in the next video. What would be good is just to give our trees crowns, which is the top part of the tree. Because we've gone over an hour, I'm so annoyed. I really thought I'd keep within 45 minutes. I'm going to treat myself to maybe copying and pasting my prepared code. So, although I have done it very differently, I've done it much more neatly in the tutorial for you. So where will this be? In the mesh terrain, I do all of this in generate the terrain. In other words, I haven't made a special plant tree function. There it is. Tree system, grow a tree. There's the trunk, which we've done. Now we need the crown. Let's see if I can just nick that. I haven't really looked at that properly. So this is really lazy. So where do I need to be? I need to be in plant tree or grow tree, which is near the top. There it is, plant tree. And so again, I should just comment this. So this is the trunk. No, this is the trunky wonky. And this is the crown. Oops. Ugh. Indenting is a little bit off. Shift tab. Shift tab. There we go. So for T in range, so what I'm doing here, I've got for T in range, for TT in range, for TTT in range. So a three-dimensional grid I'm describing there. And it's going from -2 to 3. So it's 4 in the X direction, 4 in the Z direction, and then 4 in the Y direction. So in other words, I'm just creating a three-dimensional block of, or chunk of cubes. And then I'm generating a block at those positions. But these are slightly off. So I can keep the T, the TT, and the TTT. But I also need to do this. Where am I doing it? So the Y position is going to be right at the top of the tree. So actually, I need to remove another indent block. I don't want to do that block of 4 by 4 by 4 every single time I make a trunk. Just get my comments in the right place. Oh, this is eating up so many minutes. So where does Y want to be? Y wants to be plus n times 10, I guess. That would be the top of the tree. And then I want, where is its X position? Oh, I guess I can say, yeah, that's just underscore X, isn't it? And this should be just underscore Z. And yes, we've got underscore Y. I knew we needed the Y to be passed in to the first thing. Okay, there we've got it. Right, so our crown is just a really nice nested loop. 70 minutes. Did we crash? Yes. Got an unexpected keyword. Oh, tree is true. Okay, so I've done something in my prepare code, which I can quickly take out. That's not too bad. That's not too bad. There we go. I won't put emerald up there. Let's put, what would be funny on top of a tree? Like ice. So kind of blue. Again, you don't have to make trees with this. You can now, you know, whoa, make giant concrete mushrooms. Whoa, oh, that's really cool. The trees are, actually, I was going to say they're too tall, but no, I love them this big. Notice that our performance is still pretty good, and you can play around with these weird growths. Whoops. As much as you like. There we go. Right. Thank you very much for watching. We have trees / concrete mushrooms. And I'll see you in the next video. Apologies if the end of this cuts off. Sometimes my software does that. So I'll do a weird pause at the end. Goodbye. And this is the weird pause, which hopefully no one will see. So let's quit out of here. Oh, I know what I could do while it's pausing. Let's go and go to the main module and say we've done the trees, or started them at least. Ah, we could do this next video. So let's move you over there. Tuck 22. Item 1. Deplete stack when building. And double goodbye.